This is a 220 volts geared DC motor. Now this is the RPM at 60 volts and this is its full RPM at 220 volts. Now if we compare its power with DC motors of similar sizes, it is only 50 watts while others are peaking to as high as 1 kilowatts, 1000 watts. Another point is this one cannot operate at 12 volts, which is very important for a DC motor. And guys, I got another panel from Loom Solar. It is 125 watts and 12 volts. Now guys, when I'm going to connect this motor, okay, one is already connected, one wire. Now this piece is not working because its voltage is very high, so obviously it is not going to work. If the voltage had been lower, it could have started running. So let's modify its winding. Now guys, I've removed all the previous copper winding and I'm going to use this thick copper wire. Let's measure it. You see 0.92 mm. So I'm going to use this one and then turn it into a 12 volts high current DC motor. I'm planning on giving it maximum possible turns per pole for maximum core utilization and power for this motor. Now you can see I've already removed the insulation. Copper is very thick and it's going to be a little difficult for me to manage it over here. And here as you can see that I've used 2 commutator slots as one single commutator, unlike the previous case. Now guys, to make sure that I have given correct number of turns per pole, I'm going to do the resistance check. So yeah, all the poles seem to be fine. So let's assemble it back and test it. Now, because I'm using much thicker winding than before, so the current rating is going to increase considerably, and for that reason I should change the motor wires. And here as you can see that I'm using these two 4mm cables.
Next level. Next level.
So now that the assembly part is fully complete, let's test it. So guys, this is my solar panel and I'm going to do the current testing, short circuit current testing now with my multimeter. The current is on and let's short circuit it and then connect my clamp meter. Yeah, and here we have around 4 amperes, 3.96 and fluctuating. So I think that should be enough. Oops, I was covering up my solar panel, my mistake. So here as you can see that it is producing 5.36 amperes, which is very good. It is also not very sunny right now, but still it is generating around 5.3 amperes. Brilliant. Let's test my modified DC motor with it. And you see that I've connected this piece. This connecting piece is of rubber and this is of metal, so it is going to be a little bit shaky, but let's test it. Okay, so I'm connecting the motor wires finally. Oh, one wire connected. Let's hold it with clips. And finally the last one, and it should start. And here it is running really good. Wow. And nice performance and superb high torque. Unstoppable. So that's my solar panel, 120 watts, 125 watts, and it is powering up my high current DC motor. Let's measure the amperes it is drawing. At present it is only 1.3 amperes. So it is pretty efficient. No load current is very less. And guys, now as you can see that it is also working with my 12 volts battery with a no load current of only 0.85 amperes at 12 volts. So it is even less than 12 watts, which is quite efficient. Hi guys, you're watching channel Mr. Electron, and today in this video I'm going to salvage some useful components from an old dead 1 kilowatts 20 years old home inverter. So guys, here as you can see that finally I have managed to salvage this huge transformer from the inverter. As you can see, it is really big, and for comparison I'm going to use this small UPS transformer, and you can see how small this piece is when compared to the inverter transformer. Now these 4 wires that you see, these are quite thin, and if we move on to the other side, you see these wires, these are really thick when compared to the other side. So this side is going to be your high current low voltage side, so the other one is going to be your high voltage and low current side. Now comes the part of finding out which wires should we connect to the supply. So here I'm going to use this multimeter, and let's point the meter to resistance checking mode. So first let's check these 2 wires, and here we have 3.3 ohms. Now let's go for these 2, 4.5, which is a little higher. Now the last one, 4.7 or 6, so it is the highest of the rest. So we are going to use these 2 for connecting to the mains. But before you proceed with that step, always perform the series connection test. So for that you are going to need one 100 watts bulb and connect 2 wires like this. You see, these are jumper wires. So 2 wires connected over here like this. Next, take one of the wire and connect it to the transformer. So now we have 2 left out wires in total, this one and this one. So these 2 will be connected to our home socket supply. So I'm going to use this for powering up my transformer. 1 wire connected. Now comes the other one. Yeah, and here we are done. Now let's turn on the switch. Now this bulb should glow a little bit if it's working. I'm not sure if it is glowing or not. Yeah, and now it is glowing. I think you can see. I'm going to turn off the lights. So it is glowing, really dim, but yes, it is glowing. And the next part is measuring the voltage at the output wires. So for that, I'm going to reuse my multimeter, and this time the pointer has to be set at AC voltage measurement mode. So yes, I think it's clear enough. First, I'm going to measure this voltage. As you can see that it is 9.68 volts AC. So of course it is working. Let's move on to the other one. And this one is also the same, 9.68. Now this one and this one. And it is as high as 20 volts AC. Quite high. So yes, our transformer is working perfectly fine. And one final thing, short circuit these 2 wires. Okay, I'm going to touch them and the bulb should glow brighter. You see, it's glowing bright, which means that the wiring that we have done is perfectly fine. Same for the other one, and these 2 also. Nice. So here we have a great salvage this time, a huge transformer. So this time it is a little dangerous. 1 wire connected, comes the other one. Now let's turn it on. Nothing happened. Okay. Well, I didn't hear any humming sound, so let's connect this bulb at the load. You can see it is 24 volts and 250 watts. Okay, so turning it on once again. Yeah, so the transformer is so efficient that there is no humming sound at all. It is silent, actually silent. Nice. Now let's increase the input power to the bulb, since it is a 24 volts bulb, and the good thing is that we have that combination. Now turning it on once again. You see, it is much brighter this time. Wow. Let's turn off the lights. Turning it on. Whoa. It is smoking hot. So that's our bulb. It's connected like this, and this time I'm going to turn it on and let you hear the humming sound. Let me know if any. Do you hear anything? So here I'm going to do some ampere measurement, 600 amps. So at present it is DC. Now it is AC RMS. Turning it on. Here we have around 9.5 amperes. Nice. So guys, finally the components that I have salvaged are 1 socket, 2 switches, high ampere switches, 1 small transformer for operating the relay, 1 PCB with so many components and heat sinks, MOSFETs, 1 huge relay case for future use, and most important, a transformer, 1 kilowatt transformer. Now guys, this is what I 3D printed this time. So this is the screw, and it's going to go like this. So link to buy this product has been provided in the description. You can check it out from there. And yes, of course, it is free for first 12 hours. So this is how you are going to assemble it. Now comes its use. So this, what you see, is a multimeter, and at the back of it you can see the double-sided tape. So all you have to do is take your multimeter, it can be any multimeter, and stick this piece at the back of it like this, and you're done. So this piece is going to be your multimeter stand. Okay, it works quite nice. Now here, as you can see, that the display is really dim, so I'm going to adjust it, and here we have it, even better this time. So this is how we are going to use it. It's quite simple and easy, and the best part is that this stand does not make this meter bulky. It is still quite handy. You can still use the clamp meter without any problem. And when you need the stand, you just open it and you have it. Hi guys, this what you see is an old vacuum cleaner motor. Now if you look closely, you will find the commutator, brushes and one of the field windings, which indicates a universal motor. Now let's focus on the label. As you can see, it's showing 50 to 60 Hz at 1000 watts. So guys, now it's time to open up the impeller casing of my universal motor. The impeller looks very nice, although I highly doubted that it is going to survive the water pressure if in the future I plan on using it as a water pump. So let's give it a spin before taking it out completely. Oh. So guys, before we start with the testing part of using a vacuum cleaner motor as an electric generator, let's take a look at these universal motor powered machines. So I'm going to choose an angle grinder to demonstrate that universal motors can produce large amount of electricity. Let's start with the connections. This what you see is the thread, the angle grinder, the wires, and finally connecting to this bulb, 12 volts. Let's turn on the switch. So let's wound the thread and see if it glows. As you saw that I did not connect any external power source or battery for the field excitation of this angle grinder, and still it produced electricity upon shaft rotation. Why is that? That is because of the self-excitation, and it happens only with few universal motor operated machines, not every universal motor. Now this one that you see is a very old type of universal motor, and it is from a blender. Here, as you can see, is the commutator and the brushes. Now for close-up and inside view of the motor, you can see the armature and the field winding, not the magnets but the field winding from where the wire is coming and joining the brush slot. Now let's connect a 60 volts DC e-bike charger to this motor and see how it performs. So guys, now that you have seen it in the motoring mode, let's test it as a generator, see if it can generate electricity or not. So guys, here as you can see that I gave it a spin, but it is not generating electricity. Now let's run it in the reverse direction. Okay, here is the knob in the drill for reverse operation. Now let's try it again. And now it is working as a generator. Okay. Oh. Whoa. So bright. So guys, the mixer and blender motor is also acting as a self-excited generator, but only in one direction. Here as you can see that I've already connected the drill machine to the vacuum cleaner motor, and to the output wires of the motor I've connected this bulb once again. Okay. Now let's reverse the direction of rotation. Reversed. Okay. For either case, it is not generating electricity. So to convert it into a generator, the first step is to disconnect the field pole windings from the brush slots. After that, take another wire and connect it to one of the disconnected wires of the field winding, like this. After that, calculate the length of the additional wire needed to connect it to the other left out wire from the disconnected winding. Now connect it to the left out wire. Now in total there are 4 connections left, 2 these blue wires and 2 these brush slots. Make sure that this additional wire is not touching any metal piece. Now take 2 jumper cables and connect it to the brush slots. So guys, here I'm going to use a fully charged 3.8 volts lithium ion battery, and as you can see that the bulb is glowing very dim. So guys, here I've connected a multimeter to measure the voltage because the bulb is not glowing, so I have to make sure what the problem is. Let's check the generated voltage. So as you saw that even after adding a 3.8 volts battery, the generated voltage is only a little bit higher than that, and since the bulb is not glowing, which means that the current is even lower. So it is a disaster generator. Let's increase the field input voltage by connecting a 12 volts UPS battery. Obviously this time the generated voltage should be higher, but let's see by how much. So the voltage increased from 5 volts to 10 volts almost, but it was not enough. Let's connect a bulb. So guys, the bulb did glow, and although it acted as a generator, but the power consumed by the field winding was much higher, and for that the bulb is going to glow much brighter directly. You see, it is much brighter this way. So I would say that this is the worst generator ever for vacuum cleaner motor, unless you decide to modify the armature winding.